The note is just learn the symbols. The structure and working principles will come step by step in different topics. Okay? Hello? Have you
Okay,
understood?
sir. Yes, sir.
Okay. Now we are going to discuss series and parallel circuit. First, series circuit. What is series circuit? Look, we have here four resistors R1, R2, R3, R4. They are connected one after another. This arrangement is called series circuit. So you write the heading series circuit, then draw this diagram. Then you write a note. After you are done with this drawing, you write in series circuit, current remains same everywhere as there is a single path. Single path of current flow.
Sir, do we write everything or the one you're writing?
No, not everything, only write whatever I said. I said you write series circuit, write this one heading, then you draw this circuit diagram and my writing, not everything. Everything is there in the notes. You don't need to write everything now. Just you are writing the key points which are most important. Okay.
Okay,
Hello.
sir.
So in series circuit, we have this one very important, that everywhere the current is same. And why the current is same? Because we have a single path in the entire circuit, right? Current flow. So done. Writing is done.
Yes,
Hello.
sir.
Drawing and writing is done. Then
No, sir, not yet.
in series circuit, current remains same everywhere as there is a single path of current flow. And you see here in the circuit, it's written or labeled I, huh? I, and just above this I there is an arrow. So it's showing the current direction from positive to negative, and the current value is same everywhere. Here we have I. Also, you give here another arrow, label here also I, so that you can understand everywhere the current is same I. Okay, everyone, have you
Okay,
understood?
sir. Yes, sir. Understood.
Now, again, you see in this circuit, series circuit, we have here the power supply V, and the appliances or the devices or components we have in the circuit R1, R2, R3, R4. Among these components, the voltage is shared. V is shared among them. Like if V is here 12 volt, then these resistors, if they are identical resistor, then their voltage will be 3 volt, 3 volt, 3 volt, 3 volt. And we can say V1, V2, V3, V4. So total 12 voltage is shared among all the components. Is it clear,
Yes, sir.
everyone?
Understood. Yes, sir. Understood.
What about others? Have you understood?
Yes, sir.
Okay. Now you write that. This is second point. Uh, First point you wrote, the current remains same everywhere. Then you write here in series circuit, EMF is shared among the components according to according to the according to their resistance value. Okay, like if you have two resistors, uh, you have here 12 volt, and one resistor is having 2 ohms, another resistor is having 4 ohms. Okay, then how it will be shared? According to their resistance, the one which has 4 ohms, that will share 8 volt, and which one has 2 ohms, that will share 4 volt. Is it clear?
Sir, can
I,
you
yeah, I'm
say it
repeating it.
again?
I'm repeating it. Here we have the statement, right? In series circuit, the EMF is shared among the components according to their resistance value. So I gave you an example, like you have 2 resistors. How many? Hello?
Two.
2 resistors. Okay, I'm showing you the circuit. Here we have power supply. One is here, resistor. This one is another resistor. Okay. So here 2 resistors. So one resistor we said uh, one of the resistors, it has 4 ohm. Another one has 2 ohms. Okay. Symbol of ohms. You know this symbol, right? For ohms. Hello.
Yes, sir.
So here the first one, which one is 4 ohms, it will share 8 volt. We write here 8, and this one will share 4 volt. Have you got it? Hello? Hello.
Yes, sir.
So after this writing, you draw this circuit, then you write this equation. V equals V1 plus V2. Okay? 12 equals
Yes, sir.
8 plus 4. Got it? Hello?
Yes, sir.
So it is one of the properties of series circuit that the voltage will be shared. Current is same, but voltage is shared. Remember it, huh? The series circuit.
Okay, sir.
Now we will discuss parallel circuit. Okay, parallel circuit we'll discuss. Are you done with writing, everyone? Have you completed?
Yes, sir.
Yes, sir.
Yes, sir.
Farabi, have you understood? Farabi, Adrita, Mariam.
Yes, sir.
Okay. We are going to parallel circuit. What is parallel circuit? First we understand. You see, you write the heading parallel circuit, then draw this diagram. Huh? Are you done with drawing?
No, sir.
Hello. So look here, parallel circuit. We have components R1, R2, R3, R4. All of them are connected in a way that their ends, left side ends and right side ends connected together, right?
Yes, sir.
And left side end connected together with positive terminal of the power supply. Right side end of all of them connected together at the negative negative terminal of the power supply. That makes them uh, to have the same voltage like the power supply. If the power supply have 12 volt, all the components they will have also 12 volt. Is it clear? So
Yes.
Yes, sir.
in a parallel circuit, all the components have the same voltage equal to the EMF of the power supply. This one is our first finding from this circuit. All the components. After your drawing is done, then you give these points. First point, all the components have the equal voltage, same voltage. You say same voltage equal to the EMF of the power supply. Power supply. Okay,
Sir.
hello. So all the
Yes,
components
sir.
have the same voltage equal to the EMF of the power supply. So here
Then
we gave you the example that if power supply it has 12 volts, then all the components they will also have R1, R2, R3, R4, they will also have 12 volt. Okay, this is very simple to understand. How about the current? Current is shared according to according to the value of resistance of each appliance in the branches in the branches. Okay, so here we have branches I1, I2, I3, I4. These are the currents shared uh, between all the among all the components, right? And depends on the resistance. Like if one of the branches it has components with high resistance, then there will be low current flow, right? Isn't it?
yes,
Okay, so we can give you one example with the circuit. Like we have one circuit. We are trying to understand it using a simple circuit of two resistors connected in parallel. So we draw it in another place where we have more space to show the drawing. Here, like we have one power supply here. This one is the circuit. So, for example, here we have 12 volt. Right? So, both of them they have 12 volts, right? Isn't it? Hello, hello.
Yes, sir.
So both the resistors they have 12 volt because uh, they are parallel. So all of them they will share the same voltage. Now about the current. If these two resistors they have uh, 2 ohms and 4 ohms resistance, one is 2 ohms, another one is 4 ohms. So you write here it is 4 ohms, the bigger one, and the smaller one it has only 2 ohms. You give the unit as well. This is 2 ohms, this is 4 ohms. Now what is the total resistance of the circuit? You know the formula for parallel, right? Hello, hello.
Yes, sir.
You calculate the combined resistance of these two resistors. That is the resistance of the whole circuit.
Sir,
Total
your
resistance.
voice is cracking.
Okay, so you got two resistors, right? 2 ohms and 4 ohms. Hello,
Yes, sir.
you got two resistors, 2 ohms and 4 ohms, right?
Yes, yes, sir.
So what is their total resistance?
Sir, 6.
6 if they are connected in series, but now they are in parallel. What is the formula for parallel connection? Forgot. It's written in your copy. Check. What is the formula for parallel connection? Hmm? Did you get this type of formula? 1
Sir,
by
I
R.
don't think I use the formula.
You got it. Forgot.
Sir, is it R by 1 by RP equals 1 by
So you did not
R1?
get this in last topic we discussed, topic 19. You did not get this?
Uh,
Huh?
Sir, we got it.
So why you are saying you did not get? Huh? Maimuna? So you write the value 1 by R1. What is the value of 1 by R1? This is 1 by 2, right? So 1 by 2 means 0.5, right? Then plus 1 by 4, that is 0.25. Am I right?
Yes, sir.
Then it comes 0.75. Then RP will be equal to 1 by 1 by 0.75. Now what it comes? Hello?
Sir, we
1 by 0.75. What it comes? You have to
sir one
reverse.
sir 4 to the power of 3.
1 divided by 0.75.
Sir 4 divided by 3.
Yeah, divided by 3,
4
you
by
can
3,
write
sir.
1.33. You write in decimal
Yes, sir.
form. That is more understandable to us. So it's 1.33 ohms. Now, total resistance you got 1.33. Then you can calculate now total current of the circuit, isn't it? Total current of the
Yes,
circuit
sir.
is how much? I equals V by R, right? So what is your V? V is 12, right?
Sir 12.
And what is your resistance? 1.33.
Yes, sir 1.33.
And what is the current?
Sir 9.02.
9.02.
02.
That's ampere, right?
Yes, sir.
Now, this current will be here, 9.02, it will be here, okay? And here. Got it? I is here, 9.02, I'm writing as I, that's why I labeled here I. So, left side and right side, before the branch and after the branch, we are having 9.02. When we are going to the branch, it will be divided. This 9.02 will be divided into two parts. One part will go up, another part will go down. Got it? So,
Yes, sir.
so how it will be divided? How this 9.02 will be divided depending on their resistance. So you can simply understand that the one which has more resistance, that will get less current, isn't it? So have you understood?
Yes, sir.
So the one which has more resistance, that will get less current. The one which one has less resistance, that will get more current. We understand it. Simply we understand it. Right?
Yes, sir.
Now you can also calculate. Calculate using the same formula. You have this formula. I equals V by R. This formula you can apply for also these two branches, how much current they are getting, because we know their resistance, we know their voltage. What is the resistance is clear to you, 4 ohm, 4 ohm and 2 ohms. And what is the voltage for both of them? 12 volt, right? Isn't it? Hello? For both of them
Yes,
the
sir.
voltage is 12 volt. So you just apply this V1 uh, by R, V by R1, so it will be I1 equals V by R1. So what is the answer coming? Check. 12 volt by 2. How much it is?
Sir, 6.
So 12 by 2 is coming 6 ampere, right? And the other one will get how much? 3.02, or you can say 3, simply 3, right? 9.02 means 9, isn't it? If you round it up,
Yes.
and uh, if you get I2 comes V is 12, then R2, take now, it comes 12 by 4, right? Isn't it?
Yes, sir.
So it's coming 3 amperes. So have you understood that the current depends, how much current will flow? It depends on their resistance. If the resistance is less, the current will be more. You see, for the first one, the resistance is 2 ohms. That's why our current is 6 ampere. And the second one, we have resistance 4 ohm. That's why the current is becoming half. If the resistance is double, the current is becoming half. Have you understood this, everyone? Monica? Hello? Hello? Monica? Have you understood this?
Yes, sir. Understood.
Monica, you disconnected for a while. That's why I'm asking you. Monica?
Sir, I'll watch the recording again.
No, the discussion you are getting here, have you understood this? Hello?
Yes, sir. Kind of.
Yeah. Look here, we have 9.02 current, both the sides, I and here I. Okay, before the branch and after the branch. Because current here will be the current for the whole circuit, that is coming from the formula I equals V by R. Your total resistance you got 1.33 and total voltage you got 12, so the current is 9.02. Here you understood, Monica?
Yes, sir.
Then the current is divided here according to the resistance. How? Our resistance we see here 2 ohms, and voltage is 12 volt, 12 volt, right? Because they are in
Yes,
parallel.
sir.
So we calculated it's coming 6 ampere and 3 ampere. Where the current more, we get here less resistance, right? Isn't it?
Yes, sir.
So thank you so much, everyone. Huh? Allah Hafiz.
Thank you, sir.
Allah Hafiz, sir.
Allah Hafiz.
Allah, sir.